So let's see one example about the object-oriented. It is from the book. If you have the book about the data structure and algorithms that I mentioned to you in the first week, you can see about the credit card class. So let's see the class diagram. This is the class diagram. And then you have the class name. Okay, so the class name is credit card. And there are 5 data members. As I mentioned to you, the section 2 or this section will be related to the data members. Customer, bank, account, balance, and limit. And there are 7 methods. Get customer, get bank, get account, get balance, get limit, charge with 1 argument price, and then make payment amount. So I put those code in this PowerPoint so we can easily see. First, it is the class name, and we want to make a description of consumer credit card. And then there is a constructor. In this constructor, we have 1, 2, 3, 4. So there are 4 arguments. So the customers refers to the name of the customer. Bank, it is the name of the bank. ACNT, it is the account identifier. For example, you know, the account number. And limit, how much is the credit limit? Because it is about the credit card, you know, a credit card will have a limit. So you can spend some money, but maybe not more than 10 million, not more than 10 million won, for example. The initial balance is 0. So you can see like this one. The customer name, it will be the customers with underbar customer. Bank, it will be underbar bank. Other account is account. Underbar limit is the limit, and balance equals to 0. Okay, and then let's take a look on the other functions. If I want to get the customers, there is 1 argument self. So I want to get the customer name. We use the self dot underbar customer. If I want to get what is the bank that the customer use, so I can use get bank, and then we have self dot underbar bank. If I want to know the account number, I use the get account function self. If I want to know the limit of the credit card, so I can use the function get limit self. And if I want to know the balance, I'm using the get balance self. Okay, as you know, we have 5 data members. Okay, we have 5 data members, and now we also have 5 functions. 1, 2, 3, 4, 5. So every data members, we want to get the access. So we have 5 data members, and at least we have 5 methods to access those data members. Okay, at least. This is commonly like this one. Okay. And there are 2 additional functions, or there are 2 additional methods. The first is charge. In this case, charge given price to the card, assuming sufficient credit limit. It returns true if charge was processed, false if charge was denied. So let's say now I want to know my current balance. So let's say you spend some money. Okay, let's say you have a credit card and your credit limit is back 1 million won. And then yesterday you went to convenience store, and then you buy okay. Sorry, I don't know what happened to this one. Okay. So when you look at the code later, okay, there will be a main method. what we call this is the min method. If name equals to the min, so we will execute it. So let's see the let's see the code here. Here you need to get the credit card. So we need to get the credit card class from the credit card Python file. I already give you in the E class. Okay. So we have the credit card.py. Okay, I'm going to use this one. So I already upload this one. So in the file section, you can press the upload here, or you can here do this one, upload. When you upload, it will ask you where is your file. So I put my file on the download section, and then this, and then I put on the code section. Now I'm going to use this credit card. Okay, this is the Python file that I submitted to the E-class, and then you can open it. Now you can see credit card.py. Once you double click on this file, you can see this is the credit card.py written by this guy. So this is this person is the author of the book. Oh yeah, he is one of the author of the book. And this is just the description of the file. And this is the class. The class is credit card. And the file name is credit_card.py. We have the constructor, as I already explained to you, and so on. Okay, so I already explained this on the PowerPoint that I showed before. Now we have one statement. If __ name __ equals to main. So this is the main function. So let me skip this one because I put the main function inside the Google Colab. Now this is the main function. In the main function, I'm going to create a new variable, and this variable is an empty list. Okay, I hope that you understand empty list. Last week we learned about 4 data structure: list, tuple, dictionary, and set. Okay, so I'm going to use list. This empty list, it will be added with one object, append. Append means insert or add a new object. So the object is this one. I will call the class name credit card, and I have 1, 2, 3, 4 arguments. What are they? The argument, there are 4. Customer, bank, account, and limit. So you can see here, customer name, which is John Bowman. Bank name, California Savings. And then account number, and then the limit. I think the limit is in US dollar. Okay. So this is the credit card belongs to John Bowman, and this might be the card number. And we have another card. Okay, the name is John Bowman. The bank name is California Federal, and then this is the card number, and the limit is 3,500. And okay, John Bowman also has another card. and this is the bank name, California Finance, and this is the card number, and the limit is 5,000. So it means in one wallet there are 3 cards. Okay. Now just make it simple. So let's just make it a kind of random value between 1 until 17. So this is a kind of random number. If it is 1, it means $1. If it is 2, then it is $2. If it is 3, $3, and so on. So whenever we go to those numbers from 1 until 17, let's do charging the credit card. So the credit card index 0. So it means the first credit card. The first credit card is this one. Then I will charge with the value. So if the value is 1, then I will charge $1. For credit card index 1, which is the second credit card, I will charge 2 times from the current value. And for the third credit card, I will charge 3 times from the current value. So it will be a loop. And then I would like to check. Because I have 3 credit cards, so I want to check now the status of each of the credit card. C means I want to check the credit card at the index 0, and then I want to check the credit card at index 1, and I want to check the credit card at index 2, because there are 3 credit cards. And I'm going to print for each of them. The customer on the wallet C, I want to see the customer name. I want to see the bank name. I want to see the account number. I want to see the limit, and I want to know the current balance. If the balance is higher than 100, let's make the payment. And then I want to know the new balance. So if I run this one, then the result will be the customer John Bowman. Now this is the first credit card. The limit is 2,500, but now the balance is 136. Because the balance is higher than 100, now I make the payment 100. The new balance is 36. The second credit card is this one. The balance is 272 because now the balance is higher than 100. So I need to pay. The first payment is 100, but after I pay 100, the new balance is still higher than 100. So I give another 100. Now the new balance becomes less than 100. The third credit card is also same. The balance is 400. Now I pay 100. The balance is still higher than 100. So I pay one more time. The balance is still higher than 100. So I pay one more time. This balance is still higher than 100. So I pay again. And at the end, the new balance remaining only $8. Okay, so those things are the example from the book. Okay, you can review about the code later. For the object-oriented design principles, we have some design principles that we can look into the details. The first is the modularity. The other is abstraction and encapsulation. So modularity means you can make your code as a module. If you look at your smartphone, okay, you have a lot of applications. So one application means one module. Maybe you have the module about camera. You have a module about voice. You have a module about voice recorder. You have a module about sound. You have a module about film, and etc. Okay. So we call this is modularity. Abstraction. So we will learn more about this abstraction, especially when we design an algorithm. we need to know what is the base class. In the abstraction, there will be abstract method, abstract class, interface, and etc. And we can also look at the encapsulation. So in the encapsulation, maybe I cannot explain all the things, yeah, but I'll just explain the main things of the encapsulation. For the inheritance, we will take a look because many of the algorithms will use the inheritance. For the polymorphism, I will skip. Okay, so if you want to learn more about the polymorphism, please check by your own. Modularity means we are decomposing a program into modules to reduce the complexity. If you create a big program, your code will be very long. Instead of making a long code, you can make it smaller. So make one section. You can make another section. You can make another section. You can make it another section. So there will be module 1, module 2, module 3, module 4, for example. For example, do you know median? Jungangkao. When we want to measure the median, so there will be a step. First, I have a collection of numbers, so I need to sort the number. Then we can make module 1. The module 1 is to sort the number. Second, check if the total number in a sequence is odd or even. So for example, if I have this number 2.7, 3.5, 5.1, and 8.3, the median is 3.5 plus 5.1 divided by 2. Okay, what does it mean? If the number is even, okay, it means 1, 2, 3, 4. We have 4 numbers. Then the median is the mean of the 2 middlemost numbers. The median will be the number in the index 1. Sorry, if it is index 0, it is index 1, it is index 2, index 3. Then the number of index 1 plus the number on index 2 divided by 2. However, if the number is odd, 1, 2, 3, 4, 5. If there are 5 numbers, then the median will be the mid value. Okay, so this is the median. Directly, we can determine 12 as the median. So the second module will be check whether the total number in a sequence is odd or even. If it is odd, directly determine the mid value. If it is even, then let's find the mean of the 2 middlemost numbers. Then we can create module. The first module is, this is just very simple program. Okay. In order to calculate the median, we can make module 1, which is to sort the numbers. And then we can make a module 2, which is to check the odd and even numbers. And then we can have the module 3 to check and calculation. Okay. So overall, we have this code. whenever you create an algorithm, yeah, it will be good to distinguish those parts. In this case, I have a class, and the class name is median calculator. Now I have a constructor. Constructor here is about initiating the numbers. I have the numbers, and once I have the numbers, I want to create a model sort. So this is sorting the numbers. After I sort the numbers, I would like to check whether the numbers, the length of the numbers, whether it is odd or even. Not compute equal. Exclamatory sign with equal means if it is not equal. Okay. So if it is not equal 0, if the length of the number divided by 2 is not 0, so it means this is the remaining value, namoji. So if the remaining value when we divide the numbers with 2 is not 0, then it is odd. So we will get whether it is true or false. If it is true, then yeah, you can see here. Now we have the module 3. In the module 3, the calculate median, we call the first function sort numbers, and we check the length, and then yeah, we call. If this condition is true, we do this one. If the condition is false, we do this one. Okay, so this is the separator using the module 1, module 2, module 3. When the algorithm is getting very long, maybe you need to split the class, not only the functions. Yeah, that will be your project. Okay. In the final project, later on, you need to define how many modules do you want to have, or how many class do you want to create. Okay, so that will be also one of the evaluation. Now let's see. I have this code, and then I want to use it. Okay, let's go to the Google Colab. Okay, this is the median calculator. This is based on the PowerPoint. Now I put the numbers in a list. So the number in a list is 7, 3, 5, 1, 9, and 2. So how many elements do we have? We have 1, 2, 3, 4, 5, 6. Okay, there are 6. Then, if we have 6 elements, we will check the element 3 and the element 4. And then, once we know the value of element 3 and once we know the element 4, we will do the addition and then divide it by 2. Because those numbers or those elements are even numbers. But before that one, we need to sort those numbers. Okay. So the numbers will be sorted 1, 2, 3, 5, 7, 9. After we sort this one, we know that this element and this element will be added, and then we will divide by 2. So 3 plus 5 divided by 2, then the number is 4. Okay. Then if I run this, I will just do the median calculator and we can get the median equals to 4.0. Abstraction. What is abstraction? We call it abstraction. You want to focus on the essential features while ignoring the details. Whenever we do with the algorithms later on, we will do with this abstract method. We call the abstract class, and sometimes we call it interface. But I will not explain the interface because it is a bit complicated. So you will see later about the abstract class more than the other. And maybe sometimes I will also explain about the abstract method. This is an example of the abstract class. When you know a vehicle, vehicles can have a lot of variants. For example, truck. Truck is a vehicle. Sedan. Sedan is also a vehicle. SUV. SUV is also a vehicle. And those vehicles, they share almost the same attributes. For example, on the truck, there are at least 4 wheels. Even though maybe some trucks have maybe 8 wheels, or maybe some trucks they have 12 wheels, but at least they have 4 wheels. What about sedan? The same. At least they have 4 wheels. SUV, the same. At least they have 4 wheels. So the name is different, but some of the properties, they have the same properties. They have wheels. Other things from those vehicles, so they have also steer. All of the vehicles, they share the same property, steer. But maybe the only difference is the size. The size of the steer on the truck is very big because the wheel is big. But the sedan and the SUV may have the same steer. So we got this is the blueprint. So in the blueprint of vehicle, we can say that every vehicle will have the steer. Every vehicles we have wheel. Every vehicles will have seats, and so on. If they are similar, all the properties will go to the vehicle, and we call this is the abstraction, or sometimes we call this is the blueprint. Once we have this blueprint, we can create a new class. For example, okay, I want to create a truck class. Then you can get the blueprint from the vehicles. I want to create a sedan class. Okay, I can create from the vehicle. Okay, I want to create the SUV. Okay, I can create from the vehicle. Can I create a new class? Yes. For example, gongcha, small cars. So I can create a small car. So I can create a new class of a small car. Can I create another new class? Yes, you can create another new class. For example, the RUV. Or can you create another new class? Yes, you can create a new variant of vehicles. Okay, so it means one abstract class you can use for many other subclass. So we need to understand how to create this abstract class. The abstraction, we call this is the abstract data types. The abstraction is to distill a system to its most fundamental parts. Applying the abstraction paradigm to the design of data structures give rise to the abstract data types. So before the mid exam, we will learn a lot about ADT. An ADT is a model of data structure that specifies the type of the data stored. What is the data type? And then what are the operations supported on them? And the types of parameters of the operation. So the ADT specifies what its operation does, but not how it does it. The collective set of behaviors supported by an ADT is its public interface. So yeah, I will not explain in detail for this one. I will just use the ADT more for the data structure class. For the ADT, we will check more details. Maybe next week, okay, we will learn one ADT. The other kind of design principle in the object-oriented, we call it inheritance. For the inheritance, yeah, we have an abstraction and we are using a base class. Inheritance, it is a mechanism for a modular and hierarchical organization. Module. So you can split each of the class and then hierarchy. So there's a hierarchy. Maybe we have the class and then we have the subclass and so on. This allows a new class to be defined based upon an existing class as the starting point. We call it there is a base class or parent class or super class. This is the existing class. And there will be a subclass or child class. So this is the newly defined class. So this is the same what I explained to you. This is the superclass. This is the parent class, or this is the base class. And we can create a subclass. We can create a subclass. We can create a subclass. We can have another new subclass. We can create another new subclass, and so on. So there are two ways in which a subclass can differentiate itself from its superclass. A subclass may specialize in existing behavior by providing a new implementation that overrides an existing method. And a subclass may also extend its superclass by providing brand new methods. Okay. The key point is overrides and providing brand new methods. Okay, so those the key point. Let's see. I have a student class. So this student class, student, who is student? So all of you are students. But we know that in the university, there are two or maybe more than two types of students. For example, we have graduate student. All are students. But there can be graduate student, there can be part-time student, there can be exchange students, and so on. And all of them, they share the same properties, student. For example, if they are a student, then they have the name, they have the original CD, and they have the score. But what is the difference between the student and, for example, the graduate student? The difference is the credit. If you are an undergraduate student, you need to take maybe 140 credits. But for the graduate student, you need to get only 30 credits. For the exchange student, maybe they need only to take, if it is only one semester for getting the exchange, then they will need to take maybe 12 credits and so on. So those kind of things will be different for each of the student. Then we can create a subclass. Now I have a class, this one, the student. This is the class student that we had before. And I'm going to create a new class, which is graduate student. If you look at this class, this class graduate student, we have one statement that is inside of the parenthesis. And inside of parenthesis, we want to know who is the parent class. For this graduate student, the parent class is student class. So in this case, this is the parent class. Then we can show something like this one in the class diagram. This is the parent class, or this is the super class, or this is the base class, and this is the child class. Okay. And usually we represent this with an arrow. We know that the graduate student will inherit. Okay, we call it inherit. The graduate student will inherit all the properties in the student class. And if you look at this one, okay, we have the constructor. The constructor is init, and then we have two arguments, student name and the student CD. Because we are looking at the parent class, which is student, now we write the statement super. Okay. Super. Super means I want to get the properties from the super class. From the super class, the init is to get the student name and the student CD. So I need to verify the student name and the student CD is on the super class, which is the student class. And the remaining, it will be the properties of this graduate student. Now, let's see. I can have two classes. Then I have instances about student, just a basic student. And I can also have an instance about the graduate student. So if it is a student, you already know, I can verify that the student name is Yahya and he lives in Yoi. And the second student is Bernardo and he lives in Seoul. So the data will be this one for the first student, and this is the second data. Now I'm going to create a new object, G1, and this object is a graduate student. Now let's suppose this student, I'm just using the same name. Okay, let's say the student name is Yahya. Yeah, you know, in Korean there are some names, they are the same. Okay, let's suppose the student name is the same, but it's different person. He lives also in Yoni. Now we have S1, which is a student object, and the name is Yahya, and he lives also in Yoni. Whenever you try to connect with the method, if you get the student name, Yahya, and whenever you get the S1, get student name, the result is Yahya. When you got the student CD, the result is Yungin. And when you get the S1 get student CD, the result is Yungin. When you use the G1 get maximum credit, you see the result is 30. But when you use the S1, you cannot call this one. Why? The maximum credit is not possible. Why? Because it belongs only to the graduate student. You cannot, as a student, you don't have the access to this method. But as the graduate student, because it inherits the student, so you can use all the methods from student. Okay, one more time. As a graduate student, because you inherit from the student, you can use all the methods here. But as a student, because you do not inherit anything to the graduate student, you cannot use this one. This is only for the graduate student. So we call this is inheritance. Okay, you can try. This is the class student, and this is the class graduate student. So I have S1 is Yahya Yongin. I have S2 Bernardo Zoom. Okay, and I have G1. G1 refers to the graduate student. For the S1, of course, because it is from the student, you can access anything from the student. You can access the student name, you can access the student city, you can access the student score. What about the G1? Actually, the G1, yeah. Oh, I think I have. Okay, you can access G1.get student name. You can access G1 get student city. You can access G1 and get the student score. So all properties from the students you can inherit. For the G1, you can get the maximum credit. But for the S1, I cannot get the maximum credit. S1 is an object from the student, not from the graduate student. S1 is an object from student. G1 is an object from graduate student. It is different. So when I try to use the S1 get maximum credit, then it will be error. Student object has no attribute get maximum credit because it is different. Okay. Okay, let's have a break. I'll continue after the break.